started off talking about this model of tastes, right, where we first looked at some assumptions regarding tastes. Now we want to look at how do we represent tastes. Now here we can represent taste mathematically using what we'll see utility functions, and we can represent taste graphically using what we call indifference curves. We're going to first move on to the graphical form and indifference curve, and then we'll look at later the mathematical form, which is utility function. So let's start with graphing tastes. So the idea is, how do we represent taste graphically? We do this through what we call indifference curves. Now the question arises, what are indifference curves? Indifference curves are a set of all those consumption bundles you are indifferent between, i.e. those that give you the same level of happiness. So now, what do the assumptions you made imply about the shape of our indifference curves? Now we started off this topic by talking about some assumptions regarding taste, where we talk about completeness, transitivity, monotonicity, convexity, and continuity. So we want to see how each of the assumptions we have made in this model of tastes, what will they imply about the shape of our indifference curves. We'll start with the completeness assumption. Now the completeness assumption, like if we recall, it says that individuals that you can rank or compare any two bundles. Right? That's what completeness assumption says, that you're able to rank or compare any two bundles. Are you able to tell whether you prefer one bundle over the other or you're indifferent between them? In terms of indifference curves, which are written for short as ICs, implies there is some IC indifference curve passing through every bundle. Right? So basically, in terms of indifference curves, the completeness assumption implies that there'll always be some IC indifference curve passing through every bundle, because you need to have some indifference curve passing through a bundle, right? Because for those bundles that lie on the same indifference curve, they would give you the same level of happiness. Bundles that would lie on different indifference curves, they would give you different levels of happiness. So in this way, you can compare any two bundles and tell, are you indifferent between them if they lie on the same indifference curve, or do you prefer one over the other because they lie on different indifference curves? So there has to be some indifference curve passing through every bundle. Where on the bundles that are on the same indifference curve as our bundle, you are indifferent between them. On bundles that are on different indifference curves, you would prefer one over the other. So you can always compare bundles, and that implies that there's some indifference curve passing through every bundle to allow those comparisons to happen. Second, we talked about was the transitivity assumption, which obviously talked about that those comparisons are consistent. So now transitivity assumption implies that an individual's indifference curves cannot intersect each other. So for one individual, the indifference curves will never intersect one another. Let's see why. Say if the two indifference curves of an individual's they did cross, they would share one point in common, which is point X in the figure, not below, on the right, in the figure on the right. So in this figure on the right, we are showing over here where basically we made the ICs, the indifference curves, in such a way that they're intersecting at this point X, right? So they have a point of intersection X. So trying to see what would happen if the two indifference curves did cross each other, which transitivity says is not possible. We want to see why. So let's say the two indifference curves of this individual, they did cross, and because they did cross, they'll share a point, which in this case is point X. Now this intersection point is indifferent to this bundle A because it lies on the same indifference curve as bundle A, and we know indifference curve shows all those bundles you're indifferent between. And this intersection point is indifferent to bundle E as well because it again lies on the same indifference curve containing bundle E. So because these two indifference curves intersect at point X, this point X has to be indifferent to bundle A because it's on the same indifference curve as bundle A. And we know along an indifference curve, you only have those bundles who are indifferent between those that give the same level of happiness. Similarly, this bundle X has to be indifferent to bundle E because it lies on the same indifference curve containing bundle E. But now A and E, these are two bundles that lie on different indifference curves. So they must have different levels of happiness, because we know, okay, within the same indifference curve, you have all those bundles you are indifferent between. Those that give you same level of happiness. But bundles that lie on different curves, they have different levels of happiness. So since bundle A and bundle E, they lie on different indifference curves and have different levels of happiness, so transitivity implies that the intersection point cannot be indifferent to both of them. It's not possible.